And now lastly, part C. Part C, we have the function y equals to 4x cubed, and that we are to differentiate it from first principles. The formula for first principles is that the y dx equals to limit as h tends to 0 for the functions f of x plus h minus f of x over h. Now we need to get f of x. So we simply say for f of x, we let y do the function f of x. Why? Because the function y is defined in terms of x. So we are saying we have a function in terms of x, which is y. Therefore, our f of x becomes 4x cubed. Now we are left with f of x plus h. For us to get f of x plus h, we use the function f of x. Where we find x, we substitute for it as x plus h. So here we shall have 4, x is here. After saying x, we put it as x plus h. But this cube. So we need to expand this now using one of the 3 methods. But let us operate the brackets. So that we shall have 4 times x plus h, again times x plus h, and again times x plus h. We are multiplying the bracket by itself 3 times. So let me first expand this to brackets. So here we have 4 into x squared plus 2xh plus h squared, and then times x plus h. So now we are going to multiply it again. We multiply the 2 remaining brackets. So let me extend my equal sign here. First, I have 4 there into x squared times x, I'll get x cubed. X squared times h, I'll get x squared h. Okay, this space might be small. Let me go up there. So my f of x plus h equals to markers are really disturbing. So I have 4 into x squared times x, get x cubed. X squared times h, I'll get x squared h. Now that is done. 2xh times x, I'll get 2x squared h. 2xh times h, I'll get 2x squared. Now that is done. Now we go to h. H times x, I will now plus x squared, because h squared times x is x h squared. H squared times h cubed plus h cubed in the bracket. But now we are multiplying by 4. So let us multiply all the terms by 4. This gives us the 4x cubed plus 4x squared h plus 8x squared h, yes, plus 8x h squared plus 4x h squared, yes, plus 4h cubed. Let us now collect the like terms. We have 4x cubed. Here we have 4x squared h plus 8x squared h. So we have plus 12x squared h. I'll use this 8x h squared, and this is a lot plus 12x squared, and then plus 4h cubed. So that is the function f of x plus h. First principle is really very simple. The issue is in the expansion. If you cannot expand very well, that is where you will fail. So it is important for you to know the 3 methods such that you see which one is quicker for you at a given instant. So after getting f of x plus h, then now we need to get their difference. So we say f of x plus h minus f of x equals to, this is f of x plus h, which is 4 x cubed plus 12 x squared h plus 12 x h squared plus 4 h cubed minus, open the bracket now, because f of x, oh, f of x has only one term, so we may not even put the bracket, minus 4 x cubed. So 4x cubed minus 4x cubed, they cancel. So therefore we shall have 12 x squared h plus 12 x h squared plus 4 h cubed. This is the difference of the two functions here. That is the numerator. So after getting that, then we say therefore dy dx equals to limit as h tends to 0 for, this is the difference of the function, 12 x squared h plus 12 xh squared plus 4 h cubed all over h. Now from here we divide all the terms by h. So when we divide all the terms by h, we shall have limit as h tends to 0 from, if we divide all the terms by h, we shall have 12 x squared plus 12 xh plus 4 h squared. Now from here, after dividing by h, then we say h tends to 0. So as h tends to 0, it means we substitute for h as 0. So dy dx equals to 12 x squared plus 12 x h is 0 plus 4 h is 0 but squared. So how do we finish here? We now say this term becomes 0, this becomes 0, so that we shall have only 12 x squared as the answer. Now let us see if the answer is correct. How do we check? We use the quicker method of what? Of powers and coefficients. So we have the function y equals to 4x cubed. That means that dy dx becomes 4 times 3 x cubed minus 1. This means we shall have 12 x squared. So certainly you can leave the examination room knowing that you have passed it. So this is the last example we are doing, that is example 5.